In this lesson we're going to look at radioactive decay. In the last lesson we learned that when a nucleus is unstable, it will want to change into a more stable configuration. We call these unstable nuclei radioactive nuclei. These unstable nuclei belong to what we call radioactive isotopes. And whenever the unstable nucleus transforms into a stable nucleus, one of three types of high energy radiation is emitted. So let's have a look at these three types of radiation, and we'll take as an example the nuclei of two radioactive isotopes. First of all, the one we looked at last lesson, which is the carbon-14, and we write that as C with the 14 above. That means it has a nucleon number of 14 and an atomic number of 6. Okay, so when this radioactive nuclei decays, it results in nitrogen-14 and the emission of a beta particle. And this is a beta, and a beta particle is really a high energy electron, but we'll look at this in more detail in the next lesson. And below we've got the nucleus of uranium-238, which is another radioactive isotope. So we write 238 and its atomic number is 92. And when this nucleus decays, it decays into a more stable nucleus, thorium-234. That's an atomic number 90. Okay, in this case, instead of a beta particle being emitted, as in the case of the carbon-14 decay, we get the emission of an alpha particle and a gamma ray. Okay, so that's an alpha. This is an alpha particle, which is effectively a helium nucleus, and the gamma ray, which is a form of very high energy electromagnetic radiation. Now we want to do this bit by bit, but in the next few lessons we're going to explain why, in the case of carbon, when we have beta particle emission, the atomic number increases by 1 from 6 to 7 and we get a new element, nitrogen, and likewise in the case of uranium, when the alpha particle is emitted, we get a decrease in atomic number by 2 to thorium and a reduction in the mass number, which is all to do with the types of radiation that are being emitted. So we'll talk about that in the next lesson. Really, in this lesson we're just introducing these three types of radiation. So we've got the beta particles, high energy electron, alpha particles, high energy helium nucleus, and gamma radiation, which is a form of very high energy electromagnetic radiation. Now the other thing we want to say about radioactive decay is that it is a completely random process. And let's just make a note of that first. It is completely random. That is, it is impossible to say when a carbon-14 or uranium-238 nucleus will undergo radioactive decay. All we know is that it will happen at some time. So if we have a whole lump of carbon-14 or uranium-238 symbolized by this diagram, you simply cannot say or predict, it's impossible to predict which of these atomic nuclei will decay or when they will decay. All that we can say is with certainty is that within a certain period of time, for example, in a completely random way, you simply do not know which ones will decay next. So it's completely random. All we can say is that given a certain period of time, whether these were, for example, uranium atoms or all carbon-14 atoms, within a certain period of time, exactly half of those atoms will decay. And we call this period of time the half-life. So we can say that half of the atoms in a sample will decay in a period of time called the half-life. We cannot say which ones will decay, and we cannot say when they will decay. We can say with certainty that half of these atoms will decay within the half-life of the isotope. Now this half-life will be different for different elements, so for some it may just be a few seconds, for others it may be hundreds of thousands of years. But we're going to go on and look at that in a later lesson. Now I would like to say that this process of radioactive decay occurs completely independently of any chemical properties of the material or chemical bonding. So we can say that radioactive decay is independent of chemical properties of the material. That's to say, it is a completely nuclear effect, whereas chemical properties are related to the electronic structure of the atom. And secondly, that these radioactive events, if you like, occur independently of physical properties such as temperature and pressure. Sorry, physical conditions, I should say, really, such as temperature or pressure.